Hey guys, in the previous video, we did look at regressions for chapter number 12, and we did look at the relationship between the height of a basketball player and the number of baskets they make. We added additional observations. We looked at how to find out the regression coefficients. We found out what regressions are. We made a few graphs and doing the relationship between them. And we did also learn how to get the predicted number of baskets, draw a regression line, number of baskets, and all these are done by using the data analysis and the regression tab and choosing what you want and trying to interpret the results. So in this video today, we will be looking at correlations. And correlations is the second part of the chapter number 12. And so correlation is the idea of how two variables move together. So before we actually get into what correlation is, let's look at the variance, or let's learn about the variance of a variable. So the variance of the height is how a variable moves with respect to itself. So this in Excel can be found out by the formula variance of S, and it asks for all the numbers and you could compute the variance. So the variance of the height is 99.69 and the variance of the number of baskets they make is around 18. So these are the squared versions of the regular deviations, if you could try. And this variance formula is given by sigma of x minus x bar, and you're squaring the deviations in order to give punish them in some sense, like to punish the outliers in some way you could try and think about. But covariance is the idea of how two variables move with respect to each other. It's not about how a variable moves with respect to its own mean and how diverse or dispersed the data is. So covariance is also talking about dispersion, but with respect to two variables. So instead of squaring the deviations, you multiply the deviations of one variable with respect to its mean, multiplied by the variation of the other variable with respect to its own y minus y bar, divided by n minus 1. So this is the idea of covariance, which in Excel can be found out by the covariance formula. So this is known as the covariance of first array and the second array, and you can find this. So this is 38.36. But how do you interpret this data? So what is covariance? Is this high or is this low? Does it give a high relationship, no relationship, positive relationship? It's hard to exactly know how to interpret this data. So in order to do that, Carl Pearson was one of the earliest movers of this idea, and we get to the idea of correlation. So correlation, in some sense, is just covariance divided by the standard deviation of x and divided by the standard deviation of y. So all you're doing is you're standardizing the variable, and this gives it a value between -1 and +1. So that's the idea of correlation. And if it's -1, it's perfectly negatively correlated. If it's +1, it's perfectly positively correlated. If it is 0, it has no correlation. You could think about if it's like mildly positive. If it's greater than 0, it could be like weakly positively correlated, weakly negatively correlated. You could try and think about any correlation depending on its actual magnitude of value. Let's actually look at certain figures from your textbook. And this is an example of perfect negative correlation and perfect positive correlation between two variables, right? And then you could try and look at more figures over here. So if there's 0 correlation between two variables, like the annual income and the number of children, these are the two variables. And if there's no correlation over here, that means the correlation coefficient over here are 0, right? And somewhat of a weak negative correlation. So this is typical with price. As the price of a goods goes up, the quantity demanded by the consumers kind of goes down, and price and quantity sold have some sort of a negative relationship. And the number of hours studied and college GPA, similarly here, you see the data points are a lot more clustered around each other, and this is a very strong positive correlation. Right? So this can also be thought of in terms of actual numbers. If it's only slightly above 0, it can be thought of as a weak positive correlation. Around 0.5 is a moderate positive correlation, and something closer to 0.7, 0.8, 0.9 is a very strong and positive correlation. right? And similarly, you could go think about the same magnitude of values on the negative side. So this is the idea of correlation. And in Excel as well, we could easily compute the correlation using the correlation formula. So go correlate and select the array 1 and you select the array 2. Okay, so the correlation between the height and the number of baskets is 0.9, is very strongly positively correlated. So height has a huge impact on the number of baskets a basketball player scores, unless you're Kyle Lowry. Yes. So how do you also calculate correlation manually in some sense, right? We're not going to go through all the processes, but we're going to start with this covariance. So let's try and figure out this variation. And sort of we have the variance over here. Let's also try and find out the standard deviation of each of these variables. Let's call this variable x and variable y. Okay. So this would be the square root, the variance. And so these are the respective standard deviations. So this correlation is also the covariance divided by standard deviation 1 by standard deviation 2. Right? So you see they are the same values, and this is how you obtain the correlation coefficient from the covariance by dividing it by their respective standard deviations. And correlation is a very good idea, and it should be very, very similar to the regression coefficient in some sense. So the correlation, they have a strong positive correlation, but if you want to better predict a relationship and you want to try and figure out, well, if my height goes up by 1 inch, how many more baskets can I score? Those kind of relationships are given by the regression analysis if you want to try and predict the number of baskets based on the height. Correlation just tells you whether they're strongly related or weakly related, or if they have no relation, or if they're negatively related as well. And that is shown by how close it is to +1, -1, or to 0.